Hi, welcome to another Framework 8 video. This video is about performance. What I've done is set up a load test on a site that's launched recently. It's load testing a single server on the AWS, which is a T2 medium instance. For those of you who don't know T2 mediums, it's 2 CPUs and 4 gigs of RAM. It's considered to be fairly sort of mid-range, well, low-end server, really, I would think. Now, what I want to show you on this is showing 1,000 clicks per second. So that's quite a lot of page serves, around about 3 million pages per hour. And the important thing is, even though we're getting this large throughput, we want to keep the page load times low, in this case between 15 and 30 milliseconds. So I'm just going to describe quickly the test setup that I have here. So one of the problems we've had with load testing is actually getting enough juice on the testing servers to push enough requests through to the web server. So in this case, I've spun up 3 T2X larges on Amazon with a test web stress testing tool on them called Paceler. I'm going to be simulating 350 concurrent users clicking every second from each of those boxes. That's going over a private network. I've actually set the local host, the host file up to point directly at the IP of the server, so we're not going through DNS or anything. So we're getting a true reflection of the server. And then there's a MongoDB server sitting in the back end. The back-end server doesn't really make a massive difference once the web server's up and running because of the caching. It is hit every now and then, but not often. So the first thing I'm going to do is show you the site. So I'm going to show you the site that we're going to be testing. This is one of our clients, Chesney's. Beautiful site, lovely design. We're going to be looking at all the different types of pages. We're going to be drilling down into pages which have multiple items it's showing. We're going to be drilling down into product pages, product listings. So, you know, overall, quite a good test of someone browsing around the site. I'll show you the tests in a minute. So what I'm going to do now is pop over to the load balance, the load tester servers, and here we have 3 of them, as I said, running here. Let's have a quick open there. So I'm going to run the test for 15 minutes, number of users 350, and click delay 1 second per user. And have a quick look at the URLs. So as you can see here, we're looking at the shop, information pages, news pages, find a stockist, and some product. So I'm going to kick this this test off here on this one server. So you can see all the simulated activity here as it kicks off. So these are clicks done and complete, and after that it's going there, we'll get a little report. The reports come through in stages. So there we go, 350 users click, 21 millisecond page time, which is 304 clicks per second. That's 1 million, about 1 million clicks per hour. We quickly pop over to the server that's doing the work. This is the server doing the work. So here's the load test, engb group tree ches.co.uk. So we're seeing we're using about 30% utilization on the CPU at this speed. What I'm going to do now is going to kick the other 2 servers off on their tests. There they go. So we'll come back and have a little look at this server. So we're still sitting below 30 milliseconds on the page time. Still at 1 million clicks per hour. It will vary a bit. You know, I've seen speeds up to 400 clicks per second, going down to 250, back up again. It's strange. It does kind of depend on the testing server. I think it's to do with the network configuration within AWS. But here you see we've got 3 servers running, all clicking away here, and each one, so that's 1 million clicks per hour, that's on the first server. The second server is looking at 1 million. All the page serve times up you see 30 milliseconds or less. 23 milliseconds here, that's 1,100,000 clicks per hour. So we've already hit our goal of serving over 3 million pages per hour, and we're serving those pages up quickly. So these are coming in 20 milliseconds, that's 318 clicks per second. So we're serving up 1,000 pages per second. And we have a quick look at the CPU usage. Here's the CPU usage of the web server, sitting around about 50–60% here, and that's pretty good for a T2 medium server. So what's the experience like if I wanted to then sort of browse around the site? Here's the site, and I'm browsing around it, and well, as you can see, even though we are, I'll bring the network in here. So you can see this line here is showing me how long it's taking to serve up the page. So click on Fireplaces, and that took 42 milliseconds. I'll click on Fireplaces again, and that took 18 milliseconds. You notice here I actually have turned the browser cache off, so caching is disabled on the browser. So this is the time it's coming off the server. 44 milliseconds. 20 milliseconds. Let's have a look at the news. 47 milliseconds. 21. So as you can see, I mean the experience is very good while the server's under load. If I then switch the cache back on the browsers and start browsing around, we start seeing ridiculous speeds here. There's a accessories product at 3 milliseconds from disk cache. That's a DOM content loaded in 199 milliseconds and finished in 421, which is extraordinarily quick for a site like this. So back to our goals. We wanted to test. We wanted to reach 1,000 clicks per second and 3 million pages served per hour. I think we could probably go higher. I just would need to spin a few more testing servers up to point at the single server. Now, this performance is out of the box. You don't need to configure any caching. It'll also work over multiple servers. You just install it on multiple servers underneath the load balancer, and again, no configuration required for caching. Any pages are edited, they will invalidate immediately and recache themselves across all the different servers. So we're really aiming right from the start with fw8 to really go for big performance. Thank you for watching. Have any questions or comments, please do add them to the YouTube. Thanks.